Welcome to GATE class. So today we will do the inverse Z transform, and also we will solve some problems related to Z transform. So let us do this problem. So find the inverse Z transform of Z transform of xz is equals to 1 divided by 1 minus a z raised to the power minus 1 square, and it is given that the modulus of z is greater than modulus of a. So we need to find out the z transform, inverse z transform of this problem. So how to solve this problem? So we are going to very basic signal, and the signal is x1n, and that is equals to a raised to the power n un. Now what is z transform of a raised to the power n un? So the z transform of a raised to the power n un is 1 divided by 1 minus az inverse, and the ROC is modulus of z greater than modulus of a. Now this is the z transform of this signal. Now if we multiply this signal with n, then n a raised to the power n un, the z transform is equals to minus z d xz divided by dz, and that is nothing but it is equals to minus z d by dz of 1 divided by 1 minus az inverse. Now we can solve this. We can find out the differentiation of this, and the differentiation is equals to, so n a raised to the power n un, the z transform of this is, by difference, after performing the differentiation, it is az inverse divided by 1 minus az inverse square. Now in our problem we need only 1 here. So what we can do, we can divide both sides by a. So divide both sides by a. So what we will get? We will get n a raised to the power n minus 1 un, and it is equals to 1 divided by 1 minus, it is equals to z inverse 1 minus az inverse square, and the ROC will remain same because the differentiation will not change any ROC. Now our problem is to find out the inverse z transform of 1 divided by 1 minus az inverse whole square. So what we can do, we can apply the property, and if we multiply by z raised to the power 1, so what is happening, that the z inverse divided by 1 minus az inverse raised to square, the inverse z transform is equals to n a raised to the power n minus 1 into un. Now if we multiply with z to this whole term, then what we will get? We will get the inverse z transform. We will get as n plus 1 a raised to the power n un plus 1. So finally this is 1 only. So let us summarize this. So 1 divided by 1 minus az inverse whole square, the inverse z transform is n plus 1 multiplied by a raised to the power n un plus 1. So this is the solution. Let us solve another problem. So the problem is find out the using the z transform. By using the z transform, if xn is given and hn is given, find out the response by n. So we have a LTI system. So please understand the problem. We have a discrete time LTI system. the xn is provided, and xn is equals to it is given in question that xn is equals to un, and we have yn, and the system impulse response is hn, and hn is given as alpha raised to the power n un. So hn is given, xn is given. Now we need to find out. So find out, the question is find out the response, yn. So what we need to do, we need to find out the response yn. So yn is equals to xn with hn is yn is equals to xn convolution with hn. So this is yn. Now taking the inverse Z transform on both sides, so taking the inverse Z transform on both sides, we get yz is equals to xz into hz. That yz is equals to xz multiplied by hz. Now what is xz and what is yz? So xz is equals to Z transform of xn. So it is equals to Z transform of un, and that is equals to 1 divided by 1 minus Z inverse, and the ROC is modulus of Z greater than 1. And what is yz? So yz is 1 divided by 1 minus alpha Z inverse, and that ROC is modulus of Z is greater than modulus of alpha, and that alpha is a real quantity and the value is between 0 and 1. Now what is yz? So yz is, so this is xz, of course this is as xz. So yz is hz multiplied by xz, and that sz is 1 divided by 1 minus alpha Z inverse, and xz is 1 divided by 1 minus Z inverse. So what we will get here, we can write it in this form: Z divided by Z minus 1, Z minus alpha, and further we can find out this yz by z for doing the partial fraction analysis purpose. So yz divided by z is 1 divided by z minus 1, z minus alpha. So this is our yz divided by z. Now, and ROC is, of course, it is modulus of z greater than 1. So then we can easily find out by using the partial fraction analysis. So we can write yz divided by z is equals to z divided by z minus 1, z minus alpha, and that is nothing but it is we can write it in the form of coefficients, that is c1 divided by z minus 1 plus c2 divided by z minus alpha. Now we can find out the value of c1 and c2 by following procedure. So c1 is equals to z divided by z minus alpha, and so c1 is equals to z divided by z minus alpha at z is equals to 1. So what we will get here, we will get here 1 divided by 1 minus alpha. So it is 1 divided by 1 minus alpha, and please wait, oh yeah, it is z square here, please. This is So that C1 is Z divided by C1 is 1 minus alpha, and C2 is equals to Z divided by Z minus 1, and at Z is equals to alpha. So it is equals to 1 divided by, so it is equals to 1 divided by into minus alpha divided by 1 minus alpha. So it is what is that value? So it is basically we have minus alpha divided by 1 minus alpha. So this is C2. Now yz divided by z is equals to, now putting the value of C1 and C2 in this equation, what we will get here? We will get 1 divided by z minus 1 multiplied by 1 divided by 1 minus alpha divided by 1 minus alpha multiplied by 1 divided by z minus alpha. So this is yz divided by z. Now what is yz? So yz is just, we are putting z here in this both these terms. So what we will get? We will get 1 divided by 1 minus alpha multiplied by z divided by z minus 1 minus alpha divided by 1 minus alpha, and we have z divided by z minus alpha, and the ROC is modulus of z greater than 1. So this is yz. This is yz. Now what is yn? So considering, since both signals are causal signals, so yn is 1 divided by 1 minus alpha, because 1 divided by 1 minus alpha un, first term is un, because z divided by z minus 1 is 1 divided by 1 minus z inverse. So alpha raised to the power n un, the z transform is equals to 1 divided by 1 minus alpha z inverse. Now if we put alpha is equals to 1, then it is equals to un. The z transform of un is 1 minus 1 z inverse, 1 minus z inverse. So it is we can write simply as un, and second part is alpha divided by 1 minus alpha, it is alpha raised to the power n un. So this is the z transform of this is z transform of z divided by z minus alpha, because if we see here that z divided by z minus alpha is equals to 1 divided by 1 minus alpha z inverse, so it is alpha raised to the power n un, just like here we have. So finally yn is given as, so yn is given as 1 divided by 1 minus alpha divided by 1 minus alpha. Here we can write alpha n plus 1 into un. So we can summarize this. So 1 minus alpha raised to the power n plus 1 divided by 1 minus alpha into un. So this is a final solution. So I am again telling I am again explaining the question. So we have this LTI system. This is the input. So this is the input. This is discrete time input, and this is discrete time output. This is discrete time output, and this is the impulse response of the system. This is impulse response. This is impulse response of the system, of the discrete time LTI system. And then we need to find out the output, that is response yn. So this is response. So this is response. So yn is equals to xn convolution with hn. This is the definition of convolution. Now we can take inverse z transform on both sides. We can take the z transform on both sides. So what we will get here, since the convolution in, since the convolution in time domain is equals to multiplication in z domain, so it is equals to yz is equals to xz multiplied by sz, and xn is provided, that is equals to un, and hn is also provided, that is alpha raised to the power n un. Now we are going to find out we are going to find out the z transform. So so the z transform of xn, that is un, is 1 divided by 1 minus z inverse. So z transform of un is 1 divided by 1 minus z inverse, and z transform of alpha raised to the power n un is equals to 1 divided by 1 minus alpha z inverse. So z transform of xn is 1 divided by 1 minus z inverse, and z transform of hn, that is z transform of hn is equals to hz, that is 1 divided by 1 minus alpha z inverse. That yz is equals to hz multiplied by xz. So hz is 1 divided by 1 minus alpha z inverse, and xz is 1 divided by 1 minus z inverse. Now it is written as z square divided by z minus 1 and z minus alpha. So it is equals to z square divided by, so yz divided by z is 1 z will cancel out, so it is z divided by z minus 1 z minus alpha, and the ROC is modulus of z greater than 1. Then after that we have find out the coefficients y c1 and c2. We find out the coefficients c1 and c2. So what is c1 and what is c2? So c1 we are getting as 1 divided by 1 minus alpha. So c1 we are getting as 1 divided by 1 minus alpha, and c2 we are getting as minus alpha divided by 1 minus alpha. So finally, putting the value of c1 and c2, what we will get? We will get this yz. So yz is equals to z divided by z minus 1. So this is c1. c1 is equals to 1 divided by 1 minus alpha. Here we have written yz divided by z is equals to z divided by z minus 1 and z minus alpha, that is equals to c1 divided by z minus 1 plus c2 divided by z minus alpha. Now c1 is equals to z divided by z minus alpha at z is equals to 1, that is equals to 1 divided by 1 minus alpha, and c2 is minus alpha divided by 1 minus alpha. So putting these values, we are getting yz in this form. So finally our solution is we are getting our solution as so our solution is in this form, 1 divided by 1 minus alpha un minus alpha divided by 1 minus alpha raised to the power n un. So we have just combined these two terms, and this is our response yn. Now let us do another problem. So the problem is, again we have a discrete time LTI system, and the input xn is given, and that is equals to alpha raised to the power n un, and the impulse response is given, that is equals to beta raised to the power n un. So what is the question? So question is find out yn by using the z transform concept. So xn is given as alpha raised to the power n un. So xn is provided. Now what is xz? So xz is 1 divided by 1 minus alpha z inverse, and the ROC is modulus of z greater than modulus of alpha. Now Hn is given, that is beta raised to the power n un, and Hz is provided, that is 1 divided by 1 minus beta z inverse, and it is equals to, that ROC is equals to modulus of z greater than modulus of beta. Now Yn, that z transform of Yn is yz, and it is equals to hz multiplied by xz, and that is equals to 1 divided by 1 minus beta z inverse multiplied by 1 divided by 1 minus alpha z inverse. So this is our yz. Now we can write yz in this form. So yz is written as, z square z minus alpha z minus beta. Now yz divided by z is equals to z divided by z minus alpha z minus beta, and by doing the partial fraction analysis, so we have this term equals to c1 divided by z minus alpha plus c2 divided by z minus beta. So c1 is equals to z divided by z minus beta, when we have z is equals to alpha. So putting the value of z is equals to alpha in this term, we are getting alpha divided by alpha minus beta. Similarly, the c2 is z divided by z minus alpha, putting z is equals to beta, so beta divided by beta minus alpha. This is we are getting, and we can write it is in this form, minus beta divided by alpha minus beta. So we have c1, that is alpha divided by alpha minus beta, and we have c2, that is minus beta divided by alpha minus beta. Now yz is written as, putting the value of c1 and c2 in this term, we are getting alpha divided by alpha minus beta into 1 divided by z minus alpha minus beta divided by alpha minus beta 1 divided by z minus beta. So this is yz, and what is the ROC? So the ROC is basically modulus z is greater than the maximum value of alpha comma beta. Whatever is the maximum value, the ROC is greater than this. Since z is equals to alpha and z is equals to beta, these are poles. So since it is a causal sequence, so ROC is outer to the exterior to the outermost pole. So whatever be the maximum value of alpha comma beta, the ROC, that is modulus z, is greater than the maximum value of alpha comma beta. Whatever be the value we are getting this ROC. Now since both are causal, that's why we have taken this ROC. Now Yn is equals to, if we solve that, then if we find out the inverse Z transform, then it is equals to alpha divided by alpha minus beta multiplied by alpha raised to the power n minus beta divided by beta minus alpha beta raised to the power n un. Just we have combined these two terms together, and un we have taken outside. All these things we have already covered, so please check this equation. Now whatever we means what we are getting, we can find write as this is minus, this is plus. So this is alpha n plus 1 minus beta n plus 1 into un. So this is yn. So we have conditions, we have two conditions. So when alpha is equals to beta, so what we will get? When we have alpha is equals to beta, then yz. So let us discuss these conditions. So when we have alpha is equals to beta, we have yz divided by z, that is equals to z divided by z minus alpha square, and that is equals to lambda 1 divided by z minus alpha plus lambda 2 divided by z minus alpha square. So what is lambda 1 and lambda 2? We can find out the value of lambda 1 and lambda 2. So it is better to find out the value of lambda 2 first. And lambda 1 value we will find out by doing some mathematical manipulation. So what is lambda 2? Lambda 2 is simply z at z is equals to alpha. So it is alpha. So lambda 2 we are getting alpha we have applied the definition of partial fraction. If you have any problem, you can go to previous lectures, you will find out that. And then what is so yz divided by z we can write as z divided by z minus alpha square, and that is equals to lambda 1 divided by z minus alpha plus alpha divided by z minus alpha square. Now what we can do, we can put we can set z is equals to 0. So by putting z is equals to 0, we are getting 0 is equals to minus lambda 1 divided by alpha plus 1 divided by alpha, and lambda 1 we are getting 1. So our purpose is to find out the value of lambda 1. So lambda 1 is 1 and lambda 2 we are getting alpha. So putting the value of lambda 1 by lambda 2 in yz divided by z, what we will get, yz divided by z is equals to z divided by z minus alpha plus alpha z divided by z minus alpha whole square, and that ROC is modulus of z greater than alpha, because alpha is equals to beta. So the maximum value is alpha only. So yn is we can just find out that yz. So yz is equals to 1 divided by z minus alpha plus we can find out yz as 1 divided by z minus alpha plus alpha z square divided by z minus alpha square. So if we find out the inverse z transform of this, then the inverse z transform of yn is alpha raised to the power n un for this term, plus if we just solve this, then we will find out n alpha n un, that's that z transform of this term. So it is alpha n plus 1 un. So this is yn, so yn is alpha raised to the power n plus 1 into un. This is the solution. So we get the value of yn. Now let us discuss another problem. So problem is again we have input is given. The input is equals to alpha raised to the power n un, and the impulse response is also given. The impulse response is alpha raised to the power that impulse response is given alpha raised to the power minus nu minus 1 n. So and that value of alpha is between 0 and 1. So find out the yn. So our question is to find out the value of yn. So what is yn? So yn is xn convolution with hn. So taking the z transform on both sides, so we will get yz is equals to xz into hz. So yz is equals to xz into hz. Now what is xz? Xz is equals to 1 divided by 1 minus alpha z inverse. So this is xz, and what is the value of yz? Hz. So hz is z transform of alpha raised to the power minus n u minus n. So we need to find out the z transform of this term. Here the ROC is modulus of z is greater than modulus of alpha. Now we need to find out the z transform of this signal. So that hn is alpha raised to the power minus n u minus n. So we can apply the time reversal property. So according to time reversal property, if Gn has Z transform GZ and the ROC is R, then G minus N, the Z transform of G 1 by Z, and the ROC is 1 by R. So this is time reversal property we can apply. So here the Z transform of SZ is 1 divided by 1 minus alpha inverse Z, and the ROC is modulus of Z. Now the ROC will change. So previously that ROC for this alpha raised to the power n u, and the ROC is modulus of Z greater than modulus of alpha. Now here the ROC is modulus of Z is less than modulus of 1 divided by alpha. This is the ROC. So now this is HZ. So what is the YZ? So YZ is AXZ multiplied by HZ. So YZ is XZ multiplied by YZ. And the ROC for this is alpha is less than modulus of Z is less than 1 divided by alpha. So this is the ROC. So ROC is alpha is less than modulus of Z is less than 1 divided by alpha. This is the ROC. Now what is YZ? So if we write YZ, then YZ is equals to minus 1, putting the value of XZ and HZ, we are getting minus 1 divided by alpha multiplied by Z divided by Z minus alpha multiplied by Z minus 1 divided by alpha. So this is the Z transform. This is the Z transform. Now we can find out that YZ divided by Z. So YZ divided by Z is basically it is this Z will cancel out. This Z will cancel out. So it is minus 1 divided by alpha, 1 divided by Z minus alpha, Z minus 1 by alpha, and that is equals to C1 divided by Z minus alpha plus C2 divided by Z minus 1 by alpha. Now we can find out the value of C1 and C2. So what is the value of C1 and what is the value of C2? So we can find out. So C1 is equals to we can get 1 divided by Z minus alpha when we have Z is equals to alpha, Z divided by 1 minus alpha when we have Z is equals to alpha. So it is equals to minus alpha divided by 1 minus alpha square. Please check. And C2 is equals to 1 divided by Z minus alpha when we have Z is equals to 1 by alpha, and it is equals to alpha divided by 1 minus alpha square. Please check these two values. So YZ is equals to, if we putting the value of C1 and C2, then it is equals to 1 divided by 1 minus alpha square Z divided by Z minus alpha minus 1 divided by 1 minus alpha square Z divided by Z minus 1 by alpha. And this, of course, the ROC is alpha is less than modulus Z is less than 1 by alpha. This is the ROC. Now if we just find out the inverse Laplace transform, then Yn is equals to 1 divided by 1 minus alpha square alpha raised to the power n un plus 1 divided by 1 minus alpha square alpha raised to the power minus n u minus n minus 1. So this is a response yn. This is response yn. So let us do another problem that is also related to this Z transform. So the problem is we have input xn that is equals to un, and the this yn that is equals to alpha raised to the power n un. Now we need to find out the value of yn is given. We need to find out the value of impulse response hn. So here we have given the value of xn and yn. So this is input. So this is this is the input. This is input of discrete time LTI system. This is input of discrete time LTI system, and this is response of discrete time LTI system. This is response of discrete time LTI system. So input is provided. This is input of discrete time LTI system, and this is response of LTI system. What we need to find out? We need to find out. So find out the impulse response. Find out the impulse response of the discrete time LTI system. Find out the impulse response of the discrete time LTI system. So yn is equals to xn convolution with hn. So yn is equals to xn convolution with hn. Then yz is equals to xz convolution multiplication with sz, because that convolution in time domain is equals to multiplication in z domain. Now what we need what information we have here? We have information of sz, that sz is equals to yz divided by xz, and that is equals to z transform of hn. That is equals to z transform of hn. Now yz is given. Yz is given. So yz is z transform of yn, and that is z transform of alpha raised to the power n un. So that is equals to 1 divided by 1 minus alpha z inverse. So this is basically this is yz. Yz is 1 divided by 1 minus alpha z inverse, and that hz xz is the z transform of xn, and that is equals to 1 divided by 1 minus z inverse. Now putting the value of xz, putting the value of xz and yz in this equation, putting the value of xz and yz in this equation, what we will get? So we will get hz that is equals to yz divided by xz, and the value of yz is 1 divided by 1 minus alpha z inverse, and the value of xz is 1 divided by 1 minus z inverse. So what we will get here? 1 divided by 1 minus alpha z inverse divided by 1 divided by 1 minus z inverse, and that is equals to 1 divided by 1 minus alpha z inverse multiplied by 1 minus z inverse divided by 1, and that is equals to z divided by z minus alpha multiplied by we can just write z minus what we will get here after multiplication. We are getting z divided by we can find out this, it is 1 minus 1 divided by z. So what we will get here, so finally that sz we are getting is equals to z minus 1 divided by z minus alpha. So please check this, we have just simply calculate this value of hz. So this is hz, hz is equals to z minus 1 divided by z minus alpha, and of course that ROC is modulus of z greater than alpha. The ROC is modulus of z greater than alpha. Now because this z hs that z trans hn the ROC is basically it is exterior to that circle, so we are taking this ROC modulus of z greater than alpha. Now what we are going to do, we are going to find out that sz by z. So what is sz by z? So hz by z is equals to z minus 1 divided by z minus alpha, that is equals to c1 divided by z plus c2 divided by z minus alpha. Now what is c1? So c1 is equals to z minus 1 divided by z minus alpha, and we have z is equals to 0, and that is equals to 1 divided by alpha. And what is c2? So c2 is z minus 1 divided by z, and when we have z is equals to alpha, so that is equals to minus alpha minus 1 divided by alpha. Now hz is equals to 1 divided by alpha minus 1 minus alpha divided by alpha, z divided by z minus alpha, and the ROC is modulus of z greater than alpha. So Hn is equals to 1 divided by alpha del n minus 1 minus alpha divided by alpha, alpha raised to the power n un. So this is Hn. Now if we see that at n is equals to 0, so when we have n is equals to 0, so what we will get? We will get h0 is equals to 1 divided by alpha minus 1 minus alpha divided by alpha, that is equals to 1. So we can just summarize this. So we have 1 when we have n is equals to 0, and we have minus 1 minus alpha, alpha raised to the power n minus 1, when we have n greater than or equal to 1. So when we have n greater than or equal to 1, this is our solution, and when we have n is equals to 0, this is our value of Hn. So Hn is equals to del n minus 1 minus alpha n minus 1 u n minus 1. So this is simplest solution. This is the simplest solution of Hn. This is the simplest, because Hn is equals to 1 for n is equals to 0. That means it is a del function. It is a del function because the definition of del n is equals to 1 for n is equals to 0. It is equals to 0 for n not equals to 0. And u n minus 1 is equals to 1 for n greater than or equal to 1, and it is 0 for n less than 1. So these two definitions we have used, and we have write this Hn is equals to del n minus 1 minus alpha raised to the power n minus 1 u n minus 1. So this is our final solution of impulse response. So we can solve another problem. So the problem is the output yn of a discrete time LTI system is given. The output yn of a discrete time LTI system is found to be 2 1 divided by 3 raised to the power n un when the input is xn. So it is when the input is xn, and that xn is un, that is also given. So basically that yn is given, it is given as 2 1 by 3 raised to the power n un, and xn is also given. So the part A is first we need to find out the part A is find out the impulse response, and the part B is find yn when xn is 1 by 2 raised to the power n un. So we need to find out solution of this problem. So first let us understand this problem. So we have a discrete time LTI system. So the input is xn, this impulse response is hn, then output is yn. So xn is un. xn is un in this LTI system, and hn is equals to 1 by 3 raised to the power n un. Now in this type of system we can find out in this type of system, that is yn. Okay, so yn is given and xn is given. So in this type of system we need to find out hn, and for finding out hn, it is better to take the z transform. So z transform of hn is yz divided by xz. So what is yz? So basically that yz is 1 divided by 1 minus 1 by 3 z inverse. And what is xz? So xz is 1 divided by 1 minus z inverse. So this is our hz. So hz we can write it as we can write it as 2 z minus 1 divided by z minus 1 by 3. Please check this relation. So this is yz, hz, and the ROC is basically ROC is modulus of z greater than 1 by 3. So what we can right now we can find out by using the partial fraction analysis. We can find out the sz by z. So sz by z is equals to 2z minus 1. So sz by z is so this is sz by z basically. This is sz by z. So that is equals to and this is hz. This is hz and this is hz by z. So we can write sz as by z as 2z minus 1 z minus 1 by 3, and that is equals to c1 divided by z plus c2 divided by z minus 1 by 3. That we can write in this manner. So hz is 2z minus 1 divided by z minus 3. After that we find out sz by z, that is only division by z both sides. So this sz by z we can find out, and that is equals to c1 divided by z plus c2 divided by z minus 1. So c1 we can write it as 2z minus 1 divided by z minus 1 by 3. That is if we see the relation, if we see the previous slide, then we can find out that C1 is equals to 2 divided by 2z minus 1 divided by z minus 1 by 3, because we have poles, this z by z have poles at z is equals to 0 and z is equals to 1 by 3, and the 0 is present at z is equals to 1. So here in this, for this expression, that z is equals to 1 0 and z is equals to 1 by 3 are poles. So these are poles, and z is equals to 1 is 0 and z is equals to 1 is 0. Now we can solve this problem and find out the value of C1, and C1 is 2z minus 1 divided by z minus 1 by 3 at z is equals to 0, and that is equals to 2 into minus 1 divided by 0 minus 1 by 3, and that is equals to 6, and the C2 is equals to 2z minus 1 divided by z at z is equals to 1 by 3, and it is equals to 2 1 by 3 minus 1 divided by 1 by 3, and that is equals to minus 4. So C1 is equals to 6 and C2 is equals to minus 4. So SZ is written as 6 minus 4 z divided by z minus 1 by 3, and that ROC is modulus z greater than 1 by 3. So if we find out the inverse Z transform, that then Hn is equals to 6 del n minus 4 1 by 3 raised to the power n un. This is the impulse response. So the impulse response Hn is 6 del n minus 4 1 by 3 raised to the power n un. Let us do another that B part. So the B part is now we have we know the Hn, the value of Hn. If the input we are applying is 1 by 2 raised to the power n un, now we are applying the input 1 by 2 raised to the power un, Hn we know, now we need to find out the value of yn. So yz is equals to xz multiplied by hz. So hz we had already find out in the previous problem. And what is xz? Xz, so xn is 1 by 2 raised to the power n un. Now xz is equals to 1 divided by 1 minus 2, 1 divided by 1 minus 1 by 2 z inverse. So we are putting this value, and hz is equals to 6 minus 4 z divided by z minus 1 by 3. Now if we solve this, then we will get that yz is equals to 2z minus 1 divided by z minus 1 by 2 z minus 1 by 3. Please check these relations. And so this is yz. So yz is 2z minus 1 divided by z minus 1 by 2 z minus 1 by 3, and that is equals to c1 divided by z minus 1 by 2, that is equals to c1 divided by z minus 1 by 2 plus c2 divided by z minus 1 by 3. That is equals to yz. That is equals to yz divided by z. That is equals to yz divided by z. Now we can find out the value of C1 and C2. So we can find out the value of C1, C2. So C1 is equals to 2z minus 1. C1 is equals to 2z minus 1. So this yz divided by z is So this is yz divided by z. So here we have c1 is equal to 2z minus 1, z minus 1 by 3, and we have z is equal to 1 by 2. So the value is minus 6, and c2 is equal to 2z minus 1 divided by z minus 1 by 2, when we have z is equal to 1 by 3, and the value is plus 8. So what we are getting, so putting the value of c1 and c2, thus we get yz is equals to minus 6 z divided by z minus 1 by 2 plus 8 multiplied by z minus 1 by 3. So and that of course the ROC is modulus of z greater than 1 by 2. Taking the inverse z transform, so yn is equals to minus 6 1 by 2 raised to the power n plus 8 1 by 3 raised to the power n un. So this is yn. This is yn. So in our problem, what we did, we basically in the first case we had find out the value of hz, and in the second case we have used that hz. So in the first case we had find out the value of hn, and after hz, and then in second case the new input is 1 by 2 raised to the power n un, and we need to find the output yn, that so that yz is equal to xz into hz. For this simplification of this will gives us that yz is equal to minus 6 z divided by z minus 1 by 2 plus 8 z divided by z minus 1 by 3, and of course this is both the causal sequence. Then the ROC should be exterior to the outermost pole, so it is yn is equal to minus 6 1 by 2 raised to the power n plus, and the ROC is this is our outermost pole, so this ROC is exterior to that pole. The ROC is exterior to that pole, so ROC is exterior to the pole at z is equal to 1 by 2, because the R maximum is equal to 1 by 2. In this case the R maximum is equal to 1 by 2. Now let us solve another problem. So the problem is let xn is a causal sequence. So xn is a causal sequence, and the z transform of xn is given as xz. Then we need to find out initial value. So find out initial value, that is x0, and we need to show that. So show that, find initial value x0 and show that the initial value x0 is equal to limit z tends to infinity xz. So this is our problem. So we need to prove this relation. So x0 is limit z tends to infinity xz. This is called the initial value theorem. This is called the initial value theorem in case of z transform. So this is called the initial value theorem. So this is equation number 1. So what equation number 1 tells that? Equation number 1 tells that initial value initial value can be calculated by using this relation. So now since we have considered that for this theorem we have considered that since xn is equal to 0 for n less than 0, so we have xz is equal to summation n is equal to 0 to infinity xn z raised to the power minus n. So we have started our analysis. By assuming that xn is equal to 0 for n less than 0. That means we are considering only causal sequence. So it is written as x0 z raised to the power minus 0, x1 z raised to the power minus 1, x2 z raised to the power minus 2, and so on. So as z tends to infinity, z raised to the power minus n tends to 0 for n greater than 0. Okay, so what we will get? So thus we get limit z tends to infinity, xz is equal to x0 hence proof. So it is equal to x0 hence proof. So this is called the initial value theorem. Now we have final value theorem also. So let xn be, so we have another theorem that is called the final value theorem. So let us discuss this theorem. So let xn be a causal system, that xn be a causal sequence. Please understand that these theorems are only applicable when we are considering this, that xn is a causal sequence. So if you remember in the previous case when we have find out the we have shown that the initial value theorem x0 is equal to limit z tends to infinity xz. So in that case also we have considered that xn is a causal sequence. So here also we are assuming that let xn is a causal sequence and the z transform of xn is equal to xz. The z transform of xn is equal to xz. So if xz is a rational function with all poles strictly inside the unit circle, so the another condition is that if xz is a rational function with all the poles of xz, strictly inside the unity circle, except possibly for a first order pole at z is equal to 1, then what we are getting? We are getting limit n tends to infinity xn is equal to limit z tends to 1 minus z inverse into xz. So this is the relation. So we have limit capital N tends to infinity x capital N is equal to limit z tends to 1 and 1 minus z inverse into xz. So this equation is called the, so this is called the final value theorem. This is called the final value. This is called the final value theorem. This is called the final value theorem. So this is called the final value theorem. This is called the final value theorem. So we can prove this theorem. So how to prove this theorem? So we consider xn minus 1, and let us find out the z transform of this. So z transform of xn minus 1 is equals to, if we find out the z transform of this, then it is equals to summation n is equals to minus infinity to plus infinity xn minus 1 z raised to the power minus n. And since we have considered it is a causal sequence, so since we have considered the causal sequence, so it is equals to n is equals to 0 to n is equals to infinity xn minus 1 z raised to the power minus n. And that is nothing but if we can write it in terms that we have limit n tends to infinity summation n is equals to 0 to capital N xn minus x n minus 1 z raised to the power minus n. So if we now let z tends to 1, if we now let that z tends to 1, then from this first equation, then from 1 we have limit z tends to 1 minus z inverse xz, and that is equals to limit n tends to infinity summation n is equals to 0 to capital N xn minus 1 z raised to the power. So finally what we can get here, n is equals to 0 to capital N. What we will get here, limit z tends to 1 minus z inverse into xz, that is equals to limit n tends to infinity x capital N. So this is called the final value. So this is the final value theorem. So according to this final value theorem, so limit n tends to infinity xn is equals to limit z tends to 1 minus z inverse into xz. So this is called the final value theorem. So this is called final value theorem. This is called final value theorem. So in both cases we have considered that the signal is causal. In both cases we have considered that the signal is causal. So this is called the final value